What's up, everybody? Today we are going to do a little bit of a Plastigauge tolerance measurements on our rod bearings for pretty much our new rod bearings in our old rod that had a spun bearing in it before. And I just want to make sure and see what our end result will be. The rod bolts torque spec is about 40 foot-pounds. So that's a good thing to note. I bought this little smaller torque wrench. We're going to use that, set it out to 40 pounds. So here's the Plastigauge. The way it works is you put these little plastic tubes. They're very, very small, very thin. You place them on the bearing, and then you tighten it up to spec. And then you don't spin it, you just remove it, and it ends up getting squished. It gets squished, and then you use this measurement to see what the tolerance is. It gets squished a certain amount. There's two different ones in here. There's a green one that can measure from 1,000th to 3,000ths, which is a 0.001, 0.003. In millimeters, that's that much. And the red one, you can measure from 2,000ths to 6. So we're most likely going to measure the green one because I think our tolerance is going to be pretty tight in here. Let's open it up. I've actually never used this before, so I myself am interested on how to do this. Presumably, okay, so it just comes in this strip. I don't want to lose anything out of it. And I don't know how many little gauges come in it. That's a good question. Again, I've never used this. I'm sure some of you have. Doesn't come with any instructions. I see there's just a thin line going all across it. And so presumably you would cut off a piece, open it up, put it in there, and tighten it up. So let's open up our Amazon torque wrench. It's in Newton meters and foot-pounds, and then I see 40 right up here. We're just gonna take it up there. Maybe I can just spin this. There you go, that's easier. Hold that, spin the top. Keep going. You can feel the spring tighten up. We are now at 40 foot-pounds. Okay. If I recall correctly, the size of the bolt is a 12 or 13. I'll measure that right now. Here's a 13, too big. Here is a 12, perfect. So, I'm going to take that off. Didn't realize that it would tighten so much. Again, it's a question of temperatures. It's been kind of cold the last couple of days. And so it's also important to assemble all your engine parts in one room and let them lay in one room so they'll be the same temp. If you bring in your block from your house, it's probably going to be warmer than the rest of your parts laying in the garage. And that's not the greatest in terms of these measurements. I'm also trying to think of the best way to measure this. And I think what I can do is lay the Plastigauge on the crankshaft and then connect very carefully around it. It's most likely, if I pull these apart, still got some of that assembly lube on them. Nice and thick. Just gonna make sure everything is clean. Put it back in with the correct tabs. Easy does it. Okay. With the tabs, they face each other. Let's try this Plastigauge thing without messing up, huh? Presumably, you would use some scissors, unlike me. But, okay, so I'm just gonna grab a small piece. And it just fell out somewhere. Noob. What a noob. Oh, there it is. Wow, that is so thin. So, here's the tiny piece you're putting in there. Again, this is not like rocket science measurements. This is more like guy in the garage trying to get a really easy, quick gauge and estimation on what the tolerance will be on your engine. So we're just gonna very carefully try to put it in a position where it will be placed in such a manner where it will squish it as much as we want it. But at the same time, I don't want my crankshaft to roll. I only got 2 hands. Okay, so just reseat the bearing. Let's try it, right? You could redo this multiple times if you really wanted to. Okay, that's lightly on there. Seated it with your hands, made sure there's no crack. I'm gonna say, we're gonna be at like, we're gonna be at like 0.001. I think we're gonna be at a pretty tight tolerance. Like it's gonna squish it quite a bit. We'll see. 40 foot-pounds also. So I'll just start it off with my smaller ratchet. There we go. Just super easy. Trying to not move. Okay. Let's hope I can get the leverage for 40. I'm sure I can. That's pretty tight. I'll just do it evenly. Wow, pretty tight. Okay. I'll try to hold for some leverage here. Most people would say just lay it down, right? I guess I could do that. Seems like more than 40 foot-pounds. Okay. You better click, but it's probably just a new wrench. You gotta break it in. Okay, so of course it's not gonna move anywhere because you have that piece in there. So formerly when I tightened this up, I had some very nice and slow movement on the rod. It would, even if you stood it up and let it go, it would slowly drop. There's a lot of sticky assembly lube in there, of course. But right now, we don't have that, and thus, it ain't going anywhere. Just let it sit there for a minute, but I'm sure you can instantly undo it and check to see what the Plastigauge looks like. Okay. Let's just use a regular wrench to undo it. Sorry, not wrench, ratchet. All right. Okay. And again, most of my concern is over just this one rod bearing clearance. I don't even think I'll need to do it for the others because those were OEM spec. The bearings are OEM spec, but maybe we'll check it if we have the time. We're definitely going to check the main bearings as well in the crankcase halves. We bolt those down together as well. Well, it squished it. Wow. Okay. So probably because I have oil in there, it kind of squished it like this, but you still get a nice footprint. Take you with me. There's the footprint on. Let it focus. And let's now measure in inches how much that is. I think I was right. We are at 0.001. It is quite exactly 0.001. So we are Guten tight, my friends. Most likely you have to clean that off. You don't want the Plastigauge residue staying there once you assemble the engine, because it's, I don't think it's a lubricant. It's more of like it feels kind of waxy. So it might be kind of a wax thing. It even leaves a bit of a mark, like you have to clean it off. And then once you've cleaned it off, it feels nice and smooth again. Very similarly, you will do this test when you put the crank into the case half, and you can place one on each and then bolt it down with the two case halves, and in such a way check the tolerances there. But I think what we're going to do today is pretty much move towards assembling all the bearings inside the rods and prepping them, because they're all laying over there. I'm going to clean them up and prep them for assembly. So I'll catch you after I do that. They're all the same, right? You just clean out the old ones, clean up the inside, put in the new ones. Here's another look at the not spun bearings. Look at the wear on those. That's pretty bad. I still need to get the last screw off the oil pump, and we'll see what's going on there. So these are type RA pistons from factory. Very cool that I was able to find these. They're cheaper than forged options, but they are more expensive, I guess, than just a regular STI piston. And so look at the difference. They seem to be, they should be lighter. And I'll get a scale out here and we'll measure. The design very similar by the looks. Very similar. It's just all I can tell is this right here, material amount. And then if I put them side by side, honestly, they look near identical. But yeah, look at those old cruddy pistons. We'll keep them as paperweights. Here's the oil pump. I had to drill out the screw that was stuck. It's not the most great thing, because now I need to very thoroughly wash out this whole oil pump, because, you know, there's my screw shavings everywhere. So I'm going to probably unplug these, unplug this springed relief valve on the front. A lot of people actually put spacers on those when it's in the car. Oh, look, that came out. Cool. I was trying to get it out. So this is what the oil pump looks like inside. This mechanism is what sits inside of here. Let's try to get you positioned in there. It's just a nice circle. And then this piece sits around the crankshaft in the front. And it spins and pretty much uses kind of like this, I don't know what you want to call it, squishy mechanism? Squishing mechanism to, you know, compress your oil. And so, of course, I'm going to take this out. I'm going to wash it out. It spins okay. It had like one spot where it felt a little rough, but again, it doesn't have oil right now. It has these teeth on the sides that sit around the crankshaft and help it spin. Nothing looks apparently wrong. Usually if an oil pump is bad, you'll see like one of these will get cracked. I've seen that in the past, but yeah, not in this car necessarily right now. And so you can see the piece that came off of it right here. Usually sits on it like so. So you would screw that down with screws, and that's what pumps your oil. Interestingly, right? That's like the heart of your engine. We are now going to be replacing the main bearings on the case halves of the EJ257 engine. So what I'm observing is the front one here, and actually all of them have this additional lip or tooth. Let me actually pull one out. Okay, no, it's only on one side, and it's probably very similar to the rod bearings. These bearings are not in bad shape. Like, they have wear, but they were not wearing. And that's a very common thing for main bearings. It's rod bearings that are always under the most stress. But let's look at the new ones. Also, King race bearings, high performance. I like King. So the rear bearing right here, let me pull it out. It's going to be snug because of the way it's seated in there. Let's see if I can get a very careful leverage on it to get it out. Check out that 8mm. There we go. Give it a little pull. So, ta-da! You can see it has these ridges on the sides. And to me, it looks identical both sides, of course, except for the little seating notch or tooth or whatever you want to call it. And on the engine block or on the case tab, you will see exactly where that is. So you can see that some of them are kind of like these thinner style, and some of them, the front, the middle, and the rear, are kind of this wider style that has a trough in it. So presumably they're the more heavy-duty supporting bearings, and it makes sense that they're dispersed in these locations. But again, the wear is not bad, but we are definitely going to replace them because you took out the engine. You might as well do it all. All right, so I'm going to get a clean rag and simply wherever I remove, I'm just going to clean the surface. This surface does not necessarily need to be lubed. I almost wonder if it's better to not lube this surface so the bearing has a better, seats better and stays in place. The bearing does not need to spin. Spun bearings are bad. You want that surface dry, but you want the bearing that's inserted, you want that lubed on top. Kind of straightforward. Let me open this up and we'll just start putting these in place, and I'll show you what they look like one by one. Also, I'm most likely gonna remove the bearings again when I do a full pressure wash and simple green clean of the case halves. I'll show you what I use You could make these case halves are small enough that you could fit them in a nice clean bucket and submerge them in simple green, and then, you know, wash them off. Pretty much the important part is to get into all of these holes and cavities with pressured air or in water, and then with air to blow everything out of any shavings, any debris that could be in here, any RTV that could have fallen in there from a previous assembly. But what we're gonna do right now is put in our new bearings. We're gonna put in the crankshaft, and we're gonna use the Plastigauge to check our clearances and tolerances, because I'm pretty interested as to what those are gonna come out to. Imagine this, if your tolerances are pretty tight, like that 1,000th that we saw on the rod bearings, we probably need to consider like a maybe OEM factory spec, or even thinner, possibly oil. So, for example, usually on a higher mileage engine, I run 5W40. This engine, while it's new, with these new bearings and knowing the tight tolerances, it's probably a good idea to run the 5W30 that's recommended from the manufacturer. Common sense. If your tolerances are a little bit looser, you want a little bit more oil pressure, and so you would use a slightly thicker oil. So, you know, those new cars, for example, we owned like a Escalade, which has like the LS in it, the 6.2 liter. I think that thing took like 0W20 oil. Presumably, the tolerances in that engine were very, very small, very, very tiny. And so, sure, your engine might run thicker oil when it has really, really tight tolerances, but it might not run long. And the difficulty is cold starts. I think engines suffer, as it's been proven, the most on cold starts. When the oil is cold and very viscous and thick, sorry, not very viscous, it's very thick and resistant to flow, and you're trying to push it through all these bearings, through these holes, numerous holes in the crankshaft, in the block, etc., from the oil pump, just this little oil pump, right? So it's a lot of work. And so that's why I would recommend warming up your car, letting it idle and be in its easiest load condition, like lowest load, at least, you know, until your car is warm, and then you can go and drive it and feel confident that nothing's gonna, quote unquote, rub. You're not gonna have too much extra friction, and nothing's gonna, quote unquote, blow. And by blow, I mean spun bearing because of friction. Okay. Everything is pretty straightforward here. Trying to check. Interestingly, these bearings don't have a tooth on either side, and I wonder if that's by design. I don't know. They are for this engine. I got the correct bearings. It's just sometimes you will notice aftermarket bearings. For example, some cars, they have 2 notches, but an aftermarket bearing will have 1. Because, I don't know, because they felt like it's more compatible with, let's say, multiple cars. Or they might think like there's not such a need for the double notch, so to speak. Still seems to seat perfectly fine. What's important, of course, is that your bearings seat flush and that they seat correctly. That looks fine. We're just going to do these non-support ones on the edges that do have their little nicks and teeth marks. Yeah, you can see exactly the passages where oil flows, these little valleys. Super interesting how they did that. And And of course, it helps that this engine only has a little nick on one side, but the bearing you can see has 2 holes on this end, 1 on this end. So you can't really get it wrong because you're aligning per the little notch. That's pretty helpful. Standard bearings again, not oversized, not undersized. Kind of going for that OEM spec. All right, so I test fitted the 2 case halves together just for the sake of test fitting. You can see how the bearings line up in there. And I just wanted to seat it so all the bearings seat nicely in their natural position. Now I'm gonna lift it back up, and something I wanna say is you wanna put the case half on top that has the 1, 2, 3, 4, 5, 6 bolts, because the other one only has 1, 2, 3, 4, I believe. So when we're gonna test bolt it down for the Plastigauge, you wanna have more of the equal bolt down side. And so these bolts, the ones that are the 12 point, I think online I read 40 foot-pounds is the standard torque spec, so that's what we'll do. And then we'll take it out and see what the clearances are. I'm pretty interested if it's going to be around that same 1,000th or maybe 2. We'll check the spec. I don't know. All right, so back to how initially we were taking this apart. It's not always a straightforward thing. You gotta yank it apart together because it has these like directional pieces, and sometimes you gotta yank it free. Definitely don't hit too hard with the hammer. Sometimes a rubber hammer though is not enough to set it all free. I'll get you in a minute. All right, so we're trying to separate these two. Sometimes a rubber mallet is not enough to separate this, so you got to get a little creative on how to separate them again, because again, there's a directional kind of piece right here that connects and back here as well. So those two are the ones that usually get a little bit stuck, so to speak. So you could use like something like a wood block to help you in separating it out. Yeah, it's coming out right here. Let's see. This side needs to be set free. Set me free! Freedom! Pardon my singing skills. This one's probably stuck together pretty good because I had to tap it down. Oh, Guten tight. That's the BMW torque spec. I don't know what the Japanese word for torque spec is. Somebody look it up and comment it. The most recent Japanese thing I watched was Shogun. It's pretty intense to think that the samurais evolved to building this. Pretty cool. Ding, 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 ding. Ooh. I don't want to flip it over again, but I might have to. Just to pry it apart. Please don't fall on the floor. Yeah, it's right here that it's being a little difficult. There we go. Just gotta be very careful. Man, I gotta like oil these pins. I think that's what they're called. Directional pins. And you can tell my table is wood as well. That's very useful and very good to use a wooden table instead of like a metal table, because it eats a lot of the impact that you might get on a piece of metal, like an engine block or whatever you're working on. So just a quick tip. I'm sure a wood table will work. It would probably be way louder in here. And so, once again, this one will go on top because it has the 6 bolts, 4 long ones, 2 short ones. And we're going to readjust these bearings. Some of them moved very, very slightly. I think for the initial fitting, I don't need much lube in here because I'm not going to be spinning the crankshaft. I am just looking to get some Plastigauge measurements. All right, and just super easily fit this bad boy in here. There you go. It's like a glove. There it sits. I'm not going to spin it because it's dry. That's not my goal right now. So same Plastigauge. Let me put one piece on every one of those. Here's what we have. I put one right there, and one right there. It's so interesting that a human hair is anywhere between like 1 and 2 thousandths in thickness. And that's pretty much kind of like rule of thumb tolerance for many engines. Again, like I said, newer engines have even tighter tolerances than older engines. Older engines, especially old V8s, probably had loosey-goosey tolerances in comparison. But still, very cool to think about. Let's try to place this in there super carefully. We've got to align it correctly. Make sure we don't hit anything in any funky way. Okay. That seems to be going in the right direction. Just give it a nice push. Okay, and we're just gonna ease it in there. That went in pretty good. All right. That is seated. It's not enough to just tap it down and say, oh, it's good, like, you know, pop it back off, look at what the tolerance is, because you need the true measurement for when the block is bolted down. Look at how cool it is to see the crankshaft in there and how tight everything is. Look at how close and tight everything is. The bottom of your piston pretty much nearly touches those areas. Like, everything in the engine is so well calculated, and when you spin a bearing, the piston skirts start hitting the bottom. They could hit, you know, the valves, depending on the clearance to valves, because a lot of engines are what they call interference type engines. So the timing is very important. Setting your timing chain or belt in the case of the EJ257. So EJ257 is an interference engine. You got to be careful with the timing, or else boom shack. Let me get the bolts, we'll put them in. Here are my Earl Grey delicious blend bolts. Look at those bad boys. I might lube them up a little bit so that they're easier to take out, because I don't want to struggle taking these out later. And they still have the washers on them. A lot of people reuse these, and I most likely will reuse these. I do have a set of nice head studs that we're gonna replace the factory head bolts with, because those are the ones that undergo the most pressure with tuning and combustion boost and ignition, all the above. Okay, on the end here, I believe you have to use 2 shorter ones. Let me check where those are at. Are these the ones I need? Nope, those are too short. So I think I still use the long ones up in there. Where is my magnet to pull that out? It's kind of a mess in here right now because I got a lot of projects going on. Doing a lot of stuff for myself and other people. And no one, including myself, wants to sit and spend time cleaning up after some kind of maintenance job or some kind of quick job. But I will learn one day. I know some people have pristine garages and pristine shops. I guess I will be that way when I don't work a full-time demanding job and get to do this sometimes on the weekends for my fun. You know, this is my getaway from the demands of life. Okay, if I recall correctly, those are a 13. A singular 6-sided one will not work. You need a 12-sided, as stated before. I have a 14 right here. Let me test it. No, it's 13. Is it? Here is a 12. Oh, it's a 12. I apologize. Again, I don't have all this memorized. So we're going to really kind of hand tighten it first. Just easy hand tighten. I'm going to go in a cross pattern. We're not torquing it down right now. So come on. Okay. Okay. Let's do this one. Let's see if I can see them kind of come closer together as I slightly tighten this. Yeah, I see the small crack gets smaller, so to speak. 40 foot-pounds, we'll bust out the small new torque wrench again, and we'll click it to the 40 foot-pounds. And then someone will say, you gotta flip it over and put in the others. You know, maybe we'll do that. What's the extra 5 minutes to do that? But I honestly think this is plenty of torque to tell you tolerance that's like going to be very close to what you expect. Just give it a nice kind of one hand tightening. Cool. Mr. Torque Wrench, your turn. These instructionals are not always, this instructional papers always get in the way. Everything is super tight. There's nearly no crack. It looks like it's, you know, pretty much near fully bolted down from a quick perspective from myself. $40. Yeah, let's just do a crisscross. Put a little knee to it. Wow. 40 is actually plenty. Seriously? By the looks of it, the bearings are slammed towards each other. Everything did fit super nice and easy. We are not going to spin the crankshaft, but when we're assembling the engine, the final assembly, we're definitely going to lube it up in there. And once you put it in, you want to spin it over and make sure that it spins nicely without any portion of it feeling like it is getting stuck or jamming. That means some kind of debris is most likely fallen in there. And that would be a reason to take it back apart and figure out what that is. Okay, cool. So there you have it. Now I'm going to take those out and we're going to look at the Plastigauge. All right, we've pulled it off. On the middle part, it's squished pretty good. On the back, it's squished pretty good. It seems like a lot of it was left on here. But let's measure these out and see what they are exactly. And we will call it a day for today. Okay, here's our measuring stick, measuring guide. Probably gonna start with the rear. From the looks of it, it's a 1.5 thousandth. So on the most squished part, 0.015. Over here, you gotta kind of shove it in there. It looks like between 0.015 and 0.002. And then of course, if we check on the bearings themselves, it's about a 0.002, maybe 0.003. So I'm gonna say it's about almost 2 thousandths. So good clearances overall. I'm probably gonna break in the engine and use a 5W30 because of the new bearings and the fairly tight clearances that are gonna be resulting in this. Thank you guys for tuning in to this fourth episode of the EJ257 build. I appreciate you joining us on the channel. Feel free to subscribe, comment, leave your comments. I am learning doing this. I've built, maybe fully built one engine before with forged internals. And so this is kind of another side project that I'm doing and I'm enjoying it, taking my sweet time. If you have comments and recommendations for me, please do leave them. And yeah, welcome to the channel. Catch you in the next one for the engine build. Take care.